Today I'll be talking about virtual SAN. I don't know if anyone seen the Nutanix session that Raymond and Matt just did a couple of minutes ago. I'm sure at the end of the session a couple of guys will have questions about the difference between virtual SAN and Nutanix, but hopefully the session will make it clear what the big difference is. The title of the session is It Changes Everything, and the main reason for it being is to me virtual SAN and the whole hyperconverged evolution that's going on is a true evolution, just like virtualization was when it started out 10, 12 years ago. I think it's a similar thing, right? Back in the day when virtualization started, we all had our physical servers, we loved the physical world. The world changed, we started creating these virtual machines, and something similar is happening in the storage space. So there's a true evolution going on, and whether that's VSAN, Nutanix, or even a platform like FEP from Pernix Data, the world is changing once again. So as I said, today I'll be talking about virtual SAN. The agenda is up on the slide. I'll start up with a short introduction. I'll discuss some of the requirements of virtual SAN. I'll briefly touch on the architecture. Virtual SAN is fairly simplistic in terms of setup, so hopefully we should be able to cover that in a couple of minutes during the configuration walkthrough. And I'll also look at some of the virtual machine provisioning operations, and I can already tell you that again, that's going to be it's going to look really simplistic. That's the key thing when it comes to virtual SAN. So let's start what virtual SAN actually is, and VMware likes to call this a hypervisor converged storage platform. And the main reason we started using hypervisor converged storage platform is because it's not a hyperconverged platform, it's a platform that actually sits within the hypervisor. So that's the key differentiator between what VMware has and what a lot of the other parties have to offer today. As I mentioned, the key differentiator between what VMware offers and the other parties offers is the fact that virtual SAN actually sits within the hypervisor. On top of that, virtual SAN is a scale-out storage system. With that meaning, if you have a single, or if you have a small environment with 3 nodes for virtual SAN, and you add an additional node, the capacity of that additional node and the performance of that additional node will be added to your cluster. So it scales out. As you scale out your cluster, it grows as you grow your cluster as well. And that actually happens in a dynamic way, so it's non-disruptive to your environment. So as soon as you add a node, it will automatically be added to that cluster itself. On top of that, of course, virtual SAN is optimized for flash, like any of the new storage environments out there, basically to ensure that the performance that your customers require is actually there. And because it sits within the hypervisor, of course, we integrate with all of the features and functionality that VMware has to offer. So in this case, we're talking about functionality like vSphere HA, for instance, vMotion, DRS. But of course, we also integrate with VCAC, vCenter Orchestrator, but also things like VDP, so data protection, and vSphere replication. The other key thing when it comes to virtual SAN is that it's all about the virtual machine. As soon as you start talking to storage vendors, the one thing they always want to talk about is performance, disk, or flash. All of you guys probably seen Joe's keynote, and Joe's keynote was primarily about the application, because that's in the end what you guys are all doing. You're all trying to provide a platform for the applications to land on. And that's what we tried to do with virtual SAN as well. So what we did, we didn't only build virtual SAN on top of that, or next to it, we actually built what we call a storage policy-based management system. And a storage policy-based management system basically allows you to specify characteristics for your virtual machines or your applications and tie those to a virtual machine. So in other words, if you have a virtual machine and it needs to have specific capacity requirements or it needs to have specific performance requirements, you can tie that to a specific policy, or you can specify that in a policy and tie that policy to a specific virtual machine. Now, the nice thing about virtual SAN on top of that is that you can do that on a virtual disk basis. So if you have, for instance, a large SQL database and your log files need a different, for instance, performance characteristics than your actual database files, you can specify that in a policy and tie that policy to that specific disk. Now, what I always like to show is, the difference, what it used to be, or probably what it's like for most of you guys today, and what it looks like in the virtual SAN world. So the big difference between virtual SAN and a traditional storage system is the list of the tasks that you need to do in order to provision a virtual machine. So today, if you want to provision a virtual machine, you go out to your business owner, you have a discussion with your business owner, you ask him what his requirements are in terms of availability, in terms of performance. Based on that, you're going to look at your spreadsheet, hopefully, and then look at the spreadsheet, try to figure out on which LAN it should end up on, and place that virtual machine on that LAN. Now, if something changes, you need to migrate that virtual machine from your data store A, which has performance characteristic X, to another data store, right? So that's a storage vMotion action. It's a manual task. Some cases it takes 5 minutes. Depending on how fast your storage system is, it could also take 4 hours, who knows? With virtual SAN, that's completely different. As I've already said, you specify a policy. You attach the policy to a virtual machine or to a virtual disk. If something needs to change, you either attach a new policy or you change the policy itself. So you're not moving the virtual machine around, but you're simply changing a policy. And as I said, the policy contains characteristics, and you can simply change one characteristic. And I will show some examples of what those will look like, so it makes it a bit easier to understand. Now, as soon as you start talking about virtual SAN, one of the things that always comes up is, what's a typical use case for virtual SAN? And there have been some debates about this. Let me make it absolutely clear that this is not a support statement. These are the use cases that VMware is going after today, primarily because it's a 1.0 system. So what we're targeting today are Tier 2 and Tier 3 applications, VDI. But for instance, a use case that often comes up is, for instance, a management cluster in larger environments, or DMZs, so fully isolated environments. The reason being is, if you have a shared storage systems, if you have a large legacy shared storage system, and it's shared between your regular environment and your DMZ, then guess what? In some way, there's a security issue here, because you're sharing your regular storage system with your highly secure environment, right? So if for whatever reason a virtual machine manages, or a hacker manages to break out of a virtual machine, he could access potentially files on your storage system, and by using, for instance, VSAN in a fully isolated environment, that's not possible anymore. So those are some of the use cases when it comes to virtual SAN. Now, as soon as we start talking virtual SAN, I think it's useful to know that virtual SAN is a fully software-based solution. So if you have servers running in your environment today, you need to make sure that these are on the HL, and you can start using VSAN. Now, in the majority of cases, I would expect customers to start looking at new hardware when they start doing virtual SAN. And the main reason for it being is when you start doing virtual SAN, there are some requirements when it comes to running virtual SAN, and those typically are in the typically we're talking about flash, so you need a flash device, you need some spindles, and preferably 10 gig networking. Now, when you start building a virtual SAN node, you can do that in 2 ways today. And the first way is simply buying what we call a virtual SAN ready node. So virtual SAN ready nodes are pre-configured systems which are pre-configured by some of our partners like Dell, HP, or HP is actually working on it. So it's not on the list today, it should be on the list fairly soon. Cisco is on the list, Supermicro, Fujitsu, so there's a whole bunch of vendors who have the so-called virtual SAN ready node system sitting there. So you can simply pick one of those, they are pre-configured, and they will work out of the box with virtual SAN. So all of the components are guaranteed on the HL. Now the other option that you have is, of course, building your own host. So just imagine in your environment, you're running primarily HP DL380s, for instance. HP is not on the ready node list today. Now, what you can simply do is you go to the HP website, you select some of the components, and you go to the VMware website and look at the HL and try to figure out if the components are on the HL. So there are 3 components which are absolutely critical for a VSAN environment to be on the HL. So the first component is the disk controller. It's kind of weird because a lot of people probably wouldn't expect that to be the most critical component, but the disk controller handles every single I/O. So make sure that the disk controller is on the HL. If the disk controller is not on the HL, I can guarantee you that if something goes wrong, VMware support probably won't help you. Main reason for it being is it's not tested, so we don't know what to expect. We don't know what kind of issues to encounter. So at that point, you're on your own. Now, there's a long list of disk controllers on the HCL today, so that shouldn't be a problem. It doesn't matter if you're using HP or Dell or even Supermicro, or you just want to pick a random LSI controller. There's a very long list, so you can pick any you want. The second part, which is important, is the flash device. So that could be an SSD device or PCIe today. We're also looking at Diablo, for instance, which is not on the list today. It's something that's being looked at, so that should be on the list shortly. So pick any of the SSD devices which are on the HCL, and you should be good. And then the third part, of course, is the spinning disk, so the magnetic disks. So as I've already mentioned, there's a couple of requirements, and I've already mentioned the SAS drives or the flash drives, the magnetic disks. But of course, there's also the boot device that you need to use, and also the networking. So the main reason I listed the networking here is that there's a confusion now that I would say a lot of people think that it's mandatory for virtual SAN to use a 10 gig network connection. That's not the case. So virtual SAN is fully supported with a 1 gig networking connection. Of course, there are performance implications, potentially. That's all going to depend on your specific use case. If you're running a large database server, it is doing a massive amount of IOs, yeah, surely that 1 gig link could be your constraint at some point. For the majority of environments, I would even suspect that a 1 gig link should be sufficient. So let's drill down into these flash devices, because I think the flash devices are critical when it comes to performance. We've seen some customers running performance tests, and VMware claimed or did an announcement at VMworld where they said, well, we hit 2 million IOPS. Customers running a similar test, and they hit 40,000 IOPS. So the main question they had is, what happened? What did we do wrong? Well, the key thing here was the flash device that they use. Surely when you want to have 2 million IOPS, you need to make sure that you're running or using flash devices that are also capable of delivering that kind of performance. So the next question that typically comes up is for those 2 million IOPS, which in some way isn't really relevant, and I'll come back to that later on. What kind of flash devices did VMware use? VMware used regular Intel flash devices, which are not the PCIe flash devices even, but just the regular S3700 flash devices, which are used by a lot of the storage companies out there for a good reason. But when it comes to flash, the key thing to understand is flash is used by virtual SAN in 2 ways. Flash is used for read caching, and flash is used for write buffering. So by default, your flash device, 70% of your flash device is used for read caching, 30% is used as a write buffer. This also means that every single write that you do from a virtual machine perspective will go to flash first and then to magnetic disks later. So the performance from a write perspective is always determined by the flash device that's backing those spindles. So when you start looking at these flash devices, what VMware did in order to make your life a bit easier is we classified these flash devices in the HCL. So in the HCL, you can look at the flash devices that are listed. Basically what we did, we classified them in 5 different ranges. Now if you look at the Class E devices, here we're mainly talking about things like Fusion IO cards. Fusion IO, Intel S3700 devices, and then the lower you get, also these options probably get cheaper. When I start looking at configurations, I always look at the Class D and Class E devices for a good reason, because it's, like I said, it determines the performance, but not only the performance, also the availability, because a lot of these higher end ranges, flash devices, from an availability perspective, resiliency perspective, their behavior is a lot more predictable than the cheaper end and the lower end devices. So we have a couple of requirements when it comes to these devices, and the main requirement being the amount of full writes a drive can endure. Basically, each drive should be capable of taking 10 drive writes per day for 5 years. Now, the majority of enterprise class drives will be capable of doing that, and all of the drives which are today on the HCL for sure will be capable of doing that. So that shouldn't be too big of a concern if you're using the HCL itself. Now, as I said, virtual SAN uses these flash devices for caching and for buffering. So there is a recommendation when it comes to sizing your environment. And the recommendation used to be fairly simple. It used to be 10% ratio in terms of flash versus magnetic disk. So 10% of your total capacity should be your flash capacity as well. So in the past, it used to be if you had 1 terabyte worth of flash capacity, 100 gigs worth of SSD would be sufficient in terms of how you would size your environment. Now we changed that slightly. What we did is we realized that when you start building or start deploying virtual machines, a lot of these virtual machines could be having a 100 gig disk, but because they're all thin provisioned, they may only be using 10 gigs, for instance. So we changed these recommendations and made them, from a architectural perspective, it sounds a bit more difficult, but from a cost perspective, it's beneficial to use this new rule. So the new rule basically is 10% of projected capacity, used capacity, before failures to tolerate are considered. And with failures to tolerate, meaning that before any type of replication has occurred within virtual SAN. So the example up on the board is if you have a virtual machine which takes about 50, or has a virtual disk which has, or has a 50 gig virtual disk, and of that 50 gig virtual disk, only 50% is used, and you have 100 of those, you would normally end up with 2.5 terabyte of disk capacity consumed. Now, out of those 2.5 terabyte, you need to ensure that from a flash perspective, to provide the proper performance to your virtual machine, you have about 250 gigs worth of flash capacity within your cluster. So that's not per host, within your cluster. In other words, if you have 5 hosts in your cluster, the requirement would be to have 50 gigs worth of flash capacity per host. The third, or the other thing that I mentioned already is the magnetic disk. When it comes to magnetic disks, there's a couple of key things to remember. A lot of storage companies, when they start talking about magnetic disks, they will tell you that the speed of the magnetic disk won't matter. So in other words, it's really irrelevant if you use the 7200 RPM, the 10K RPM, or the 15K RPM disks. Well, to VSAN, in my opinion, it does matter, because although every single write should hit SSD at first, at some point it will need to be destaged to a magnetic disk. So guess what? If you have really, really slow, large disks, it's going to take a long time before those IOs are all destaged to the magnetic disks. Not only will it take a long time before those are destaged to a magnetic disk, but what about the reads? As I mentioned, VSAN typically has a 70% read cache on those flash devices, but at some point an IO is not going to be sitting in cache, but it needs to come from disk. So the slower your disk will be, the slower your IO will be, if the IO will need to come from disk. So typically the 10K disks are a sweet spot when it comes to performance and capacity. If for whatever reason, from a budget perspective, for instance, 10K disks wouldn't fit your budget, and you're aiming to use the cheaper SATA drives or the 7200 drives, I would highly recommend to go to NLSS. The main reason for it being is that NLSS is basically the same drive as a SATA drive. The difference is it has a different controller, and the different disk controller has a larger queue depth. So in terms of performance, it typically performs about 20–30% better than the SATA drives. I've already mentioned that the storage controllers are really important. It's difficult today to figure out from a performance perspective what these storage controllers do. So there are really cheap controllers. So for instance, for Dell, you can get the lower end controllers. For LSI, you have the lower end 2008 controllers as well. They are a couple of $100, so they're a couple of €100, so they're quite cheap. The downside of those cheaper disk controllers is that they have a lower queue depth. Now, why is the queue depth important? In the case of virtual SAN, for instance, you may end up running 50 or 60 virtual machines on a single host. So just imagine you have 60 virtual machines on a single host. All of those virtual machines are just doing one IOP. So that's 60 IOPS a second. The queues of the lower end disk controllers only take, the queue depth of the lower end disk controller is about 25. So you can see what the problem is going to be here, right? So you have a queue depth of 25. You have 60 virtual machines doing I/O. So congestion is going to take place, which means that the I/O is going to sit in the hypervisor instead of being pushed down to disk. So the key thing to consider when you start looking at a virtual SAN environment is make sure that from a disk controller perspective, you use a higher end disk controller which has a larger queue depth. So from a performance point of view, you won't have a bottleneck in terms of pushing down the I/O to disk. And as I've already mentioned, the network is an important part. So that is one key thing that a lot of people haven't realized yet or haven't heard about yet. And it's not the use of 1 gig versus 10 gig. but it's the fact that the distributed vSwitch is included with virtual SAN. So if you end up buying a virtual SAN license, you get a distributed vSwitch license with it. So as soon as you enable it, you have the distributed vSAN license, or you have the distributed vSwitch license. Now, the nice thing about having the distributed switch license is that you can use something like network I/O control. So even if you're not using 10 gig networks, for instance, but you have multiple links, you have these, the network I/O control to your disposal, and you can use the links with different types of VM kernels. So you can have vMotion traffic, you can have management traffic, and VM network traffic all running over the same links. And you can use network I/O control to make sure that these traffics don't interfere. The other consideration, which is probably stuck away somewhere in the documentation, it's something that a lot of people have skipped for whatever reason, is when is the boot devices for the ESXi. So when you install vSAN itself, or configure vSAN, I should say, vSAN uses what we call vSAN tracers, and these are basically the log files, and the log files are stored on a scratch disk. Now, the scratch disk by default is something that's being used by ESXi, and it can either be done in memory, it can also be done on disk. So depending on the amount of memory you have available in your system, there is a specific architectural decision to be made in terms of boot device to be used. So any host that has more than 512 gigs of memory, it's mandatory to use a rotating media, so a magnetic disk, as a boot device for virtual SAN. Or you could do a boot from SAN as well, but then again, why would you have vSAN if you have a SAN anyway sitting there which you can boot from, right? So if you have less than 512 gigs of memory, you can do any type of boot device you want. So now that we know some of the requirements, let's look at some of the technical characteristics of vSAN and the architecture. So I've already mentioned that there's a lot of players in this space, and there's a lot of competition in this space as well, and I think this is where we differentiate from a vSAN perspective. The big difference between vSAN and between any of the other solutions out there is that this is tightly coupled with the vSphere environment. With that meaning that if you go into your vSphere cluster, you open up your cluster object, you go to properties, you will see a tick box, and the tick box, that's the tick box how you enable virtual SAN. That's the only thing you will need to do well. Of course, you will need to create a network as well. But in order to create a virtual SAN environment, this is the only thing you will need to do. Tick that tick box, and I'm pretty sure that most of you guys should be able to do that. At least I was capable of doing it, so I guess even Massimo can do it. So when it comes to implementing it, of course, there are some requirements. As I said, it's really easy to implement it. Yes, it's really easy to implement it. It's going to take only one click. vSAN enabled, yes. But as I mentioned, of course, there are some requirements for enabling vSAN. First of all, you will need to make sure that you have at least 3 nodes in your cluster contributing some form of storage. That's the minimum amount of nodes needed. So depending on the size of environment that you're working in, if you're looking for the 2-node cluster vSAN solution, unfortunately, that's not possible today. The maximum today is 32 nodes, which aligns with the boundary that HA and DRS has today, and hopefully in the future when HA and DRS are capable of scaling out to 64 or 128 nodes, vSAN will nicely scale along with it. That's definitely something that we'll keep in mind, and that's definitely something that should be possible in the future as well. Now, from a requirements perspective, the other thing that's, of course, requirement on the node level is to have 1 flash device and to have at least 1 magnetic disk, because you need to have some form of capacity being contributed to the vSAN cluster. Now, as soon as you start building these vSAN clusters in the UI, you will notice that there are some new terminology, some new constructs, and some new artifacts that pop up. So, for instance, for vSAN, one of the new terms that's being introduced is disk groups. There's also something called the vSAN data store. There are objects, there are components, and of course there's the virtual SAN network. So let's drill into those, each of those individually. If you look at the virtual SAN disk groups, and a lot of you will probably never even see these, because when you enable vSAN, you have the option to enable vSAN either in fully automated mode or a manual mode. And when you set it up in fully automated mode, guess what? Virtual SAN creates these so-called disk groups for you. If you set it up in manual mode, then you will need to create these disk groups yourself. But it's not difficult to create these. So a disk group basically is a logical construct. It's a pool of disks in a local host. So a single host has an X amount of disks. That could be 1 to 7 disks and one flash device. And that forms a disk group. And that disk group allows you to store virtual machines on top of a VSAN data store. So each of your hosts will have at least one virtual SAN disk group. And all of these disk groups, as I just mentioned, form a virtual SAN data store. And the nice thing about a virtual SAN data store is that it's exactly the same, or at least it looks exactly the same from a UI perspective as a regular SAN data store. So from a virtual machine provisioning point of view, as soon as you start provisioning virtual machine, and I will show that in a second, you will notice that there's absolutely no difference between legacy storage or a virtual SAN data store. Now here comes the difficult part. So you have virtual SAN object, and a virtual SAN object is formed out of multiple components. So a virtual SAN object is basically could be a virtual machine itself. So it could be a virtual machine, the virtual machine namespace as we like to call it, a virtual disk, or a virtual swap. And an object is nothing more than a file or a thing being stored on the virtual SAN data store. Now this object is formed out of multiple components. And why is it formed out of multiple components? Well, let's assume you have a 3-node cluster and a node fails. If you only have one component of an object and the node fails where that object is sitting or the component is sitting, then you just lost your virtual machine. So what I drew out here from a component perspective is an environment, or at least an environment where you have multiple copies of your data, and it's also being striped. So depending on how you set up your policies, you could see an architecture like this popping up. But I will show an example in a second. But these objects and these components basically form the basic foundation of your virtual machine. And then thirdly, but not least important, is the virtual SAN network. So the virtual SAN network is used by all of the virtual machines and the hosts to communicate to each other. Right? So that's either storage I/O or the virtual SAN network informing the other node what the status is of the nodes itself. Or for instance, where virtual machines are stored, where I/O is going from left to right. So there's one key thing to keep in mind here is that virtual SAN requires layer 2 multicasting. I don't know if there are any networking people in the room. Typically when we have the discussion, or at least when we mention layer 2 multicasting, the network people aren't too happy. Unfortunately, it's the requirement today. It's something that's being looked at in the future to see how we can ease this, or at least change it so that the requirement isn't there anymore. So now that we know some of the fundamental constructs, I would like to show you what it takes to A, set up virtual SAN, B, also deploy some virtual machines when it comes to virtual SAN. So first of all, you will need to configure a VM kernel network. So who here has set up a vMotion VM kernel in the past? It's exactly the same for virtual SAN. So you set up a VM kernel, you tick the virtual SAN traffic tick box, you give an IP address, and that's all you need to do. So as soon as you set up the VM kernel on each of the nodes that's part of the virtual SAN environment, the next thing you will do is you will go to your cluster object. And guess what? Again, you will click that single tick box, and you're done. Virtual SAN will start building itself. It will take all the disks. As soon as it's taken all of the disks, the virtual SAN data store will be presented to all of the nodes, and you can start building virtual machines on top of that. Now, one thing to point out here is that when you deploy virtual SAN or when you configure virtual SAN, it's important to disable vSphere HA. So the main reason for it being is that virtual SAN and vSphere HA, they do integrate really well. But when you deploy virtual SAN and vSphere AA in conjunction, vSphere HA need to use the virtual SAN network. So by default, vSphere HA, in order to communicate between the nodes, will use the management network. When you enable vSAN, HA will use the vSAN network for the nodes to communicate to each other. The main reason we are doing that is to ensure that if anything happens to a virtual SAN environment, so for instance, a node, the NIC of a node fails for whatever reason, we're still using the same network, and we know from an HA perspective we need to fail over those virtual machines. So we want to make sure that we use that NIC to have that capability. So disable vSphere HA when you enable virtual SAN, then enable HA afterwards, or you can do it in conjunction as well, but disable it first. So as I've already mentioned, we had these disk groups. Now, if you set up virtual SAN in the fully automated way, you will never ever see this screen, because this is done by virtual SAN automatically. But if you're like me and you like to do stuff manually, you just like to figure out how stuff works, you will see the screen popping up. And basically what the screen allows you to do is per host set up these disk groups. And as I said, the disk group is just a collection of lower magnetic disks and a single flash device sitting in front of that magnetic disk. That is a read buffer or a read cache and a write buffer. So for each of the hosts in your cluster, you will need to create these disk groups. And then, again, the VSAN data store will be created automatically. Now, as soon as you've done that, which should take about 2 or 3 minutes, you can go to your regular vSphere environment, and you will see these screens popping up. On the right, you will see a map, which is the map of the virtual SAN data store with all of the hosts attached to it, which just looks like any regular environment. And on the left side, you will see the virtual SAN data store from a summary perspective. So it will show you what the flash capacity is. It will show you what the capacity is of the virtual SAN environment itself. And if you have something like VCOps, it will integrate with VCOps as well and will tell you what the health is, for instance, and what the efficiency is of your VSAN data store. So it looks like a regular data store, and that's the key thing to remember. But when I started out, I mentioned these capabilities, I mentioned these policies. And I think the policies are the key thing when it comes to virtual SAN. The main reason for it being is that the policies allow you to make changes to virtual machines or applications without doing anything to the virtual machine itself. VSAN is doing that for you. So hopefully all you guys can see this, this screen, but there are about 5 policies today, of which 2 policies, in my opinion, are key policies. The first policy being the number of failures to tolerate, and the second policy being the number of stripes you can set for a virtual disk. It's probably easier if you drill down into this by using a diagram. It's probably a bit easier to visualize it. So number of failures to tolerate is all about the hosts, the number of hosts or disks or network cards that can fail in a cluster before anything bad happens to your virtual machine. So by default, if you deploy a virtual machine without having created any policy, you will get a failures to tolerate of 1, which basically means that if host 1 fails, or in this case host 2 fails, which is running a VMDK, your virtual machine will still be available. Now vSAN allows you to specify multiple of these as well. So you can specify, for instance, a host failures to tolerate of 3. This also means you will get 4 copies of your data. So the higher the number becomes, the higher the cost of deploying your virtual machines will be as well. The majority of customers out there today are running their environment in using number of failures to tolerate as 1. So as soon as you set up failures to tolerate, the other thing to consider is something like striping. And I've already mentioned striping briefly, is that it could be important in terms of when you're flushing data to disks, or when you're reading from disk, and for whatever reason when your virtual machine is doing a read, and for whatever reason the read is not coming from cache. So if you have an application which does a lot of random I/O, at some point you will notice that the cache is going to be exhausted. Right? Not everything will fit in cache. So at that point, when it doesn't fit in cache anymore, I/O will need to come from disk. If you're running to the point where, for whatever reason, you're spindle constrained or IOPS constrained, so let's assume you have a 10K SAS disk, which does about 150, 160 IOPS, and your application requires more than that. Within your policy, you can tell the virtual machine to start using more spindles. So for instance, I could tell my virtual machine to start using 10 spindles, or 5 or 8, depending on your requirements. As soon as I change the policy itself and I apply it to the virtual machine, vSAN itself will redistribute all of the components and objects that are part of that virtual machine across the data store, across the local disk groups, but also across hosts. And that's what I'm showing in the diagram here. So striping for virtual SAN is not only within the host, but can also be across multiple hosts. So in other words, if I have a virtual machine in this case with a single disk, with a stripe width of 1, and it has a replica copy for availability as well, I could easily be running those components on 4 nodes. In this case, I'm running it on 3 nodes to show that striping either works locally or across multiple nodes as well. So there's a couple of other storage capabilities within VSAN that people may want to use. There's something called object space reservation. This is typically used in VDI environments where you see virtual desktops growing really fast. Object space reservation is basically a reservation in terms of disk capacity. So by default, when you deploy a virtual machine with virtual SAN, virtual machines are deployed in a thin way, so 0% of space is reserved, meaning that if you deploy a 100 gig virtual machine and you're not installing anything, the file size will be really, really small. It's going to be a couple of kilobytes. When you start using object space reservation, we're not actually creating a large file, so we're not writing zeros, we're just preserving the space itself. So whether you set the reservation or not, the time it takes to deploy the virtual machine is going to be exactly the same. The other two that I mentioned here are flash cache reservation and forced provisioning. Now, forced provisioning is something that I would try to avoid using at any cost, because basically what it allows you to do is deploy virtual machines while your virtual machine can't adhere to the policy itself that you've set. So let's assume you've set a policy where it states that you need to have 3 copies of your data. If forced policy is enabled, you can still deploy the virtual machine without VSAN creating those 3 copies. So if you can only create 1 copy, we'll just create 1 copy. Now guess what? If it only creates 1 copy and that single host fails, your data will be gone. So try to avoid using forced provisioning. The other option that I just mentioned is flash read cache reservation. It is what it says it is. It's a reservation in terms of read cache. So if for whatever reason you want to have a virtual machine needs to have 25 gigs of read cache reservation, you can specify that in your policy as well. But VSAN is fully capable of figuring out which virtual machine needs how much cache capacity itself. Now, when it comes to doing I/O, a typical question that always comes up is, what about the writes? So how are writes acknowledged? Well, writes are acknowledged in a synchronous way. What that meaning is, if I have my virtual machine sitting on ESXi 01, as I'm showing in this diagram, and my objects are actually physically located on ESXi 02 and ESXi 03, we won't acknowledge the write back to the guest OS until it has reached the flash layer itself. So writes are acknowledged as soon as they hit flash. We're not waiting for the spinning disks. As soon as they hit the flash, writes are acknowledged. Now when it comes to reading, virtual SAN can basically read in 3 ways. When we started the presentation, I mentioned that we have a read cache of 70%, a write buffer of 30%, and then there's the spinning disks as well. Now guess what? I/O is stored in all of those 3 places. Virtual SAN actually keeps a database and knows where the latest version of your block is stored. So depending on where the latest version of your block is stored, VSAN is smart enough to retrieve it from that specific block. So that could be from the write buffer, because if you just done a write and the I/O is only in the write buffer, then we will get it from the write buffer itself. If it's in read cache, we will get it from read cache, and if it's in disk, we'll simply fetch it from the disk itself. So let's look at the virtual SAN provisioning or VM provisioning operations itself, because I think this shows the strength of VSAN. Hopefully most of you have seen this screen 1,000 times by now, maybe 1,000,000 times, who knows. Deploying a virtual machine when it comes to VSAN is really simple. This is the key screen. The only thing you will need to do is choose the right policy. At the top you will see VM storage policy, which says FTT is 3, which basically says failures to tolerate is 3 in this case. It's a policy that I created. You could give it any name. It could be gold, silver, and bronze. Doesn't really matter. As soon as you pick the policy, vSwirl will show you which data store is compatible. Now, there's no other storage system out there today that knows how to read or knows how to understand a VSAN policy, so it will just show the VSAN data store. You select the VSAN data store, and your virtual machine gets deployed. Now, hopefully, you will see the screen up on the top right, which says virtual machine is deployed and it's compliant. If for whatever reason a virtual machine is deployed and it's not compliant, or something has gone wrong during the provisioning itself, and you had, for instance, forced provisioning, which I just mentioned, enabled, you will see a not compliant warning on your virtual machine summary screen, which basically tells you need to look at your cluster and fix the issues you have as soon as possible. As I've already mentioned, you can change these policies on the fly. One key thing to remember, though, is if you start changing policies and you change these for a lot of virtual machines, so let's assume you have 100 virtual machines and you only have one policy and need to make a change for a virtual machine, create a new policy. Don't change the existing policy, because the 99 other virtual machines that are using the same policy will also be affected by the change of that policy itself, because you're tying a single policy to 100 virtual machines. So create a new policy, attach that policy to the new virtual machine, to that virtual machine, apply the policy, and the changes will be made to your virtual machine itself. The other question that typically pops up is, what about maintenance mode, right? So what if I need to upgrade my ESXi cluster itself? As soon as you start upgrading your ESXi cluster, make changes to your environment, or need to make changes to your hardware, there's the option to run maintenance mode. And maintenance mode with this new version of vSphere 5.5 with VSAN will give you 3 options. It's ensure accessibility, full data migration, or no data migration. Now, no data migration is easy when you use VSAN. It's not moving any bits, so it's really fast. It's also probably one of the most risky options to use. The second option that I mentioned was ensure, or the first option that I mentioned is ensure accessibility. And ensure accessibility basically means I'm only going to move objects when the availability of my object is at risk. So if I have 2 objects, or if I have an object with just one component, I'm going to move that single component out just to make sure that a virtual machine is available as soon as I power down that host. Hopefully I've shown you guys that virtual SAN is really easy to use. As I mentioned, you can install and configure it in a couple of clicks. I think the key thing here is to understand that the policy-based management part is absolutely critical. It performs well. I can see Andre shaking his head because I said 100 gazillion IOPS. And that's why I said IOPS, in my opinion, is not important. It's all about the use case. So it doesn't really matter in the end which storage system you use. If it's a legacy storage system, if it's a virtual SAN storage system, hopefully it's a virtual SAN storage system, of course, but you're trying to solve a business problem here. You're trying to solve something for the application. And hopefully the policy-based management part, that's part, an integral part of VSAN, shows you that it could be very, very useful for any type of business. Last but not least, there's going to be a book released in about 3 to 4 months from now that will show you all of the details about virtual SAN and should help you deploying and implementing virtual SAN. That was it. Thanks.